Hello everyone, welcome to the certificate course on reasoning and quantitative techniques. In this video, we are going to discuss the topic speed, time and distance. Speed and distance is another fundamental topic in quantitative aptitude which is frequently tested in various competitive exams or job interviews. So these problems typically involves calculating the speed, distance or time taken when the object is in motion. So understanding these concepts is crucial for solving various practical problems efficiently. So in this video, we are going to discuss what are the speed, time and distance, what is the relation between these three, and we are going to discuss some of the formulas and solve some basic problems. Now the speed of an object describes how fast or how slow it moves, and it is calculated as distance divided by time. Speed is directly proportional to the distance and inversely proportional to time. So the relation between speed, time and distance. So the formula to calculate speed when distance and time is given is speed is equal to distance divided by time, or distance is equal to speed into time. Like when speed and time is given, we can find the distance using this formula. So distance an object travels is directly proportional to its speed. That means the faster it moves, the greater the distance is covered. Now time equal to distance divided by speed. So time is inversely proportional to the speed. So the faster an object moves, the less time it takes to cover a certain distance. As the speed increases, time taken decreases and vice versa. So units, so whenever you solve some problems in speed time, it's important to know what are the units or the SI units or the which is used to represent the values. The most commonly used units of speed, time and distances are, for the speed, we generally use kilometer per hour or meter per second, sometimes miles per hour or feet per second. For time, we use seconds, minutes or hours or rarely days. Distance, the most used units are kilometers or meters, sometimes miles or feet. To convert, it's important to from kilometer per hour to meter per second. Suppose the speed is in terms of kilometer per hour, and if you want to convert into meter per second, you have to multiply by 5 by 18. So that means 1 kilometer per hour is 5 divided by 18 meter per second. Similarly, to convert a meter per second into kilometer per hour, we have to multiply by 18 by 5. That means 1 meter per second is 18 by 5 kilometer per hour or 3.6 meter per second, meter per hour. The next concept is average speed. So average speed is total distance traveled divided by total time taken. Sometimes you can travel with the different speeds. Okay, problems will be given where different time interval or different distance, the speed will be different. So in that case, if you want to find the average speed, you have to divide the total distance traveled with the total time taken. Now case 1, if the distance is constant but speed is different. Okay, like same distance is traveled with a different speed. So in that case, average speed will be 2 into xy divided by x plus y. So where x and y are the two different speed at which the same distance has been covered. Say for example, 100 kilometer is covered, traveled at the speed of 50 kilometer per hour, and another 100 kilometer is traveled at the speed of 60 kilometer per hour. So in this case, you have to use the average speed as 2xy divided by x plus y. Case 2, when the time taken is constant, distance will be different. Say for example, first 1 hour he travels with the 5 kilometer per hour, and the second hour he will travel with the 10 kilometer per hour. And if you want to find the average speed, you have to use the formula x plus y divided by 2. Here x and y are the two different speeds. Next is relative speed. It is a rate at which two moving bodies are separating from or coming closer to each other. So we have, suppose if there are two trains with the length L1 and L2 moving in opposite directions. This is the case 1. If they are moving in opposite direction with the speed S1 and S2 respectively, then the relative speed of the train is S1 plus S2. So whenever the bodies are moving in opposite direction towards each other, then the relative speed will be, you have to add the speeds. So relative speed will be more. Similarly, time taken to cross each other, it will be total length of the train, that is L1 plus L2 divided by S1 plus S2. Suppose case 2, if the two trains are moving in the same direction with the speed S1 and S2, and if the length of the trains are L1 and L2, then their relative speed will be S1 minus S2. So we have to do like maximum higher speed minus smaller one, larger minus smaller, and time taken for the faster train to cross the slower train will be L1 plus L2 divided by relative speed. So here relative speed is S1 minus S2. Okay, so time taken will be total length to be covered or total distance to be covered divided by relative speed. One more concept which comes under in speed, distance, time is boat and stream problems. Say if the speed of a boat in still water is x kilometer per hour, and if the speed of water current, that is stream, is y kilometer per hour, then speed of the boat with the stream, it is also called as downstream. Speed of the boat will be x plus y. Downstream will be x plus y. That is speed of the boat with the stream, along with the stream is downstream x plus y. And speed of the boat against the stream, that is called upstream, will be x minus y. Remember, always downstream will be more than upstream. Now if you want to find the speed of boat in still water, so that will be downstream plus upstream divided by 2, and speed of the water current or speed of the stream will be downstream minus upstream divided by 2. So these are the some formulas which we will require. So let us solve some simple questions. So starting with, a person crosses a 600-meter long street in 5 minutes. What is the speed in kilometer per hour? Okay, you have to convert the speed into kilometer per hour here. The values are in terms of meter and minutes. Okay, now speed of the person is s1 is equal to, speed is equal to d1 divided by distance divided by t. So here distance is 600 meter, 600 meter divided by, now time is in terms of 5 minutes here. Okay, so convert into second. So 5 into minute means 60 seconds. So 5 into 60, that is 300 seconds. So 600 divided by 300, so which is equal to 2 meter per second. So the speed is in terms of meter per second. And if you want to convert into kilometer per hour, so that will be 2 into, so to convert into kilometer per hour, you have to multiply by 18 divided by 5. So that will be 36 divided by 5, which is equal to 7.2 kilometer per hour. So this is the speed of the person in terms of kilometer per hour. Make sure that you have to use a proper unit. Second question, a runner can complete a 750-meter race in 2.5 minutes. Will he be able to beat another runner who runs at 17.95 kilometers? So in order to check whether the first runner chases or beats the second runner, you have to compare their speeds. Okay, if the speed of the first runner is more than the second one. So let us check. The speed of the first runner will be speed is equal to distance divided by time. So your distance is 750 meters divided by time is in terms of 2.5 minutes. So 2.5, that is 2.5 minutes into 60 seconds. So 2.5 minutes when you convert into seconds, so that will become 150 seconds it is. Now divide total distance 750 divided by 150 is 5 meter per second, and we want to convert this 5 meter per second into kilometer. So 5 into 18 divided by 5, which is equal to 18 kilometer per hour. So this is the speed of the first person, S1. Now it is given that speed of the second person, S2, is equal to 17.95 kilometer per hour. So since both the units are same, we can compare and say that S1 is greater than S2. Okay, 18 is greater than 17.95. Therefore, the first runner can beat the second runner. So since S1 is greater than S2. Okay, next problem. While going to office, Ramesh travels at the speed of 30 km per hour, and on his way back he travels at the speed of 45 km per hour. So what is this average speed of the whole journey? Now home to office, office to home, in both the cases distance traveled is constant. So in this case, the formula for average speed will be 2xy divided by x plus y, where x and y are the two different speeds. So what are the two different speeds here? One is 30, x is 30, and y is 45 km per hour divided by x plus y. So 2 into 30 into 45 divided by 2 into 30 into 45 divided by 30 plus 45, that is 75. Okay, upon simplification we have 5 15 twos are 15 fives are, and 5 ones are 5. Upon cancellation 5 nines are, so 2 into 2 4 into 9 36 kilometer per hour. Okay, so the average speed is 36 kilometer per hour. Next question. A person travels in bicycle from his home to office at a speed of 25 km per hour. While coming back, he walks from his office to home at the speed of 4 km per hour. If the traveling part of his day, like total time for traveling is 2 hours and 54 minutes. Okay, traveling time is 2 hours and 54 minutes. So we have to find the distance between office and home. See, since in both the cases distance is constant, like home to office plus office to home, the average speed will be 2xy divided by x plus y, that is 2 into x is 25 kilometer and y is 4 kilometer, and divided by 25 plus 4, so that will be 2 into 25, 50 into 4, 200 divided by 29 kilometer per hour. Now total time taken is how much? 2 hours plus 54 minutes. 2 hours plus 54 minutes equal to, we will convert into total hour. Okay, so that will be 2 hour means 120 minutes plus 54 minutes. Total it is 174 minutes. Okay, 120 plus 54 is 174 minutes. And if you want to convert into hour, so 174 divided by 60 hours it is. Okay, now if the distance from home to office is d, now since he goes to home to office and again office to home, total distance traveled will be d plus d. Okay, total distance traveled is d plus d. which is equal to average speed into time, because average speed is equal to total distance divided by time taken. So total distance will be average speed into time. So total distance is 2d is equal to average speed is how much? We have 200 divided by 29 multiply by total time taken for the entire journey is 174 divided by 60. This cancel 29 and 6, 6 ones are, 6 tens are, 200 divided by 20, that is 20 kilometer. See, this is the total distance, home to office, office to home. So 2D is 20. So what is D then? So distance between office to home will be only D. Okay. So D will be 20 divided by 2, that is 10 kilometers. This is 20 divided by 2. Okay, so D, the distance from office to home is 10 km per hour. Problem. A man travels from his home to office at 4 km per hour and reaches his office 20 minutes late. If he travels at 4 km per hour, he will be 20 minutes late. If the speed has been 6 km per hour, he will reach 10 minutes early. Find the distance from his home to office. Again. Now, case 1. Okay, before that, let distance from home to office as D, and required time, the correct required time will be T minutes in terms of minutes. Okay. Uh, Now, when he reaches office 20 minutes late, that means total time taken. So required time will be T. 20 minutes late means extra 20 minutes they will take. So time taken when from office to home, home to office is T plus 20. Then distance, okay, D1, we'll consider it as a D1, speed into time. What was the speed? 4 km per hour into, okay, this time is in terms of minutes. So if you want to convert into hour, it will be 2 plus 20 divided by 60. So distance will be T plus 20 divided by 60. Okay, put bracket here. Now, case 2. From when he reaches the office 10 minutes early, then time taken will be, see, required time is T. 10 minutes early means he will take less 10 minutes. So T minus 10, this is in terms of minutes. So T minus 10 divided by 60 hours. Okay, this is hours. So distance, we'll take it as D2, speed into time. Second case speed was 6 kilometer per hour into T minus 10 divided by 60. Now this D1 and D2, okay, both are distance from home to office. That means D1 should be equal to D2. Now compare equation 1 and 2. So you will get 4 into T plus 20 divided by 60 is equal to 6 into T minus 10 divided by 60. So we'll cancel the 60 and 60. So this implies, okay, we can multiply 4 into T, 4T, 4 into 20, 80, and the right hand side 6 into T minus 6 into 10, 60. Now bring T's together and numbers together. 60 minus 40 is 2T, and 60 comes this side, becomes plus, that is 140, 80 plus 60, or T is equal to 140 divided by 2, that is 70 what? 70 minutes. What, 70 minutes? Yeah. Therefore, distance 70 minutes will be 70 divided by 60 kilometer per hour. Now we can take any one here, any one of the equation. We'll take the first one. 4 is equal to um, T plus 20 divided by 60, that is T plus 20, 70 plus 20 is 90 divided by 60. So 3 2s are 6, 3 3s are 9, then 2 1s are 2 2s are 2 into 3, 6 kilometers is the distance from office to home. Okay, next problem. Two trains start from stations 300 kilometers apart, travels towards each other. Okay, this is station A and station B. The gap is 300 kilometers. Okay, we have one train here and another train here. They will be traveling to each other. Now, speed of the first train is 40 km per hour and the speed of the second train is 50 km per hour respectively. How long it will take for the two trains to meet? Now, since the trains are moving in the same opposite direction, the relative speed will be S1 plus S2. So that will be 40 plus 50 is equal to 90 kilometer per hour. Time is equal to distance divided by relative speed. Now distance to be covered is how much? 300. Just to meet it is not to cross each other. So the gap between the train is 300 kilometer and the relative speed is 90. So 300 divided by 90, that is 3.33. That is in terms of hours. And if you want to convert into minutes, multiply by 60, you will get 3 hours and 0.33 hour convert into minutes, 20 minutes. So required time just to meet each other as 3 hours and 20 minutes. Okay. Next problem. A car traveling at 80 km per hour is chased by another car traveling at 100 km per hour. If the cars are initially 20 kilometers apart, how long it will take for the second car to catch up with the first car? Since the cars are traveling in the same direction, chasing each other means same direction, the relative speed will be difference. So difference you will take S2 minus S1 here. Okay, that is 100 minus 80. So that is 20 kilometer per hour. Okay, 20 kilometer per hour will be the relative speed of the car. So required time for the second car to catch up with the first one will be distance divided by total distance to be covered divided by relative speed. Now, what is the gap here? 20 kilometers apart. So 20 kilometer divided by 20 kilometer per hour. So that means 1 hour. So within 1 hour, the second car will chase the first car. Next problem. How long does a train of 90 meter running at a speed of 54 km per hour takes to cross another train of 160 meter long running at 36 km per hour in the opposite direction? So trains are traveling in opposite direction. Therefore, their relative speed, okay, will be sum. That means 54 kilometer plus 36 kilometer. So 54 plus 36 is equal to 90 kilometer per hour. Okay, now here the lengths of the train are in terms of meters, right? So we'll convert this into meter per second. Okay, 90 kilometer per hour. To convert into meter per second, we have to multiply by 5 by 18. So 18, 5 is 90. So 5 into 5, 25 meter per second it is. Okay, now total distance to be covered will be length of the train. So that will be L1 plus L2, which is equal to 90 plus 160 meters or 250 meter. Okay. So this is the total distance to be covered. Therefore, time taken will be total distance to cover divided by relative speed. That is, total distance is how much? That is the total length of the train, 250 meters divided by relative speed is 25 meter per second. 250 by 25 is 10 and the unit is seconds. So required time is 10 seconds. So within 10 seconds, train will cross each other. Next problem. A policeman sighted a robber from a distance of 300 meters. The robber also noticed the policeman and started running at 8 km per hour. Policeman also started running after him at the speed of 10 km per hour. Find the distance the robber would run before he is being caught. So now, since both are running at the same direction, so since the question is chasing, so running in the same direction, so the relative speed will be a difference. That is, policeman is 10, robber is 8. So 10 minus 8, 2 kilometer per hour is the relative speed of the policeman. Now, total distance to be covered by the police in order to catch the robber is how many meters? 300 meters. We'll see, since here kilometer per hour and meter, we'll convert this into kilometer here. So 300 meter means 0.3 kilometer. You have to divide by 1000. Okay, it will be 0.3 kilometer. Now, time taken by the policeman to catch the robber is distance divided by relative speed. Distance he traveled is 0.3 and his relative speed is 2 km per hour. So 0.3 divided by 2 is 0.15 hour. Okay. Now this is the time taken. In the question is within this time how much the robber will run. So for that distance run by the robber before he being get caught is time multiplied by speed of the robber. Okay, speed of the robber you have to do. So that will be 0.15 multiplied with the 0. Okay, speed of the robber is 8 km per hour. So 0.8 into 0.15 into 8 is 1.2 kilometers. Okay, this is the total distance the robber will run before he is being caught. Next problem. A boat travels upstream at a speed of 5 km per hour and downstream at a speed of 10 km per hour. If the speed of the stream is constant, what is the speed of the stream and what is the speed of the boat in still water? So here it's the boat and stream problem. What is given upstream? So how much is upstream here? Upstream is 5 km per hour and downstream is 10 km per hour. The direct question here. So speed of the boat in still water will be, we have downstream plus upstream divided by 2, that is 10 plus 5 divided by 2, or 15 divided by 2, which is equal to 7.5 kilometer per hour. Similarly, speed of the stream will be downstream minus upstream divided by 2. So downstream 10, upstream is 5, 10 minus 5 divided by 2, that is 5 divided by 2 or 2.5 kilometer per hour. So these are the simple questions. Okay, now, so these example illustrate different types of speed and distance problems you might encounter in general aptitude test. Practice these. Okay, you can practice many more to improve your problem solving skill and speed. Thank you for watching this. We'll meet again in the next topic.